In this video, we are studying about types of mapping. So mappings are relations between two sets. Okay, we have two major types of mapping in which we have the injective, or also called one-to-one mapping. And under this one, every element of the domain must have a unique. So let me use an example. Let's say the domain is made up of the alphabets A, B, C, D, for example. It must have a unique element in the codomain or in the range which it's mapped to. So using the arrow diagram, this is an example of one-to-one or injective mapping. So in this one, all we just check to confirm that this is an injective mapping is that we are going to consider that none of the elements of this set, of the domain set, are mapped to one particular, like not more than, everyone has their own unique pair at the codomain set, that is at this side. None of them, like this A and B, can't be mapped out to 2 or something like that. So this is injective or one-on-one mapping. Now you might also see something like this A, B, C, D as the domain, and then we see the codomain made up of 1, 2, 3, 4, 5, 6, and then we see something like this. This is still one-on-one, a one-to-one or injective mapping, because just the rule is that every member of this set is mapped to one unique, its own member of the codomain or range set, right? These ones that are not mapped to anything doesn't matter. Now let's get to the second type of mapping. We have the surjective or called onto mapping. And since a function is also a mapping that has its codomain made up of numbers, so even if you're asked for the types of function, it's also applied there. So onto mapping. For onto mapping, what we have to check is that the codomain are all mapped out. Like this can't be an onto mapping because there are some members of this set that are not mapped to the domain elements, right? So for surjective mapping, all we just need to see is that the range is equal to the codomain. The number on the range is equal to the number of the codomain. The set of, as in range, is equal to codomain set. So using these two examples that is already drawn here, this is a one-to-one mapping and as well as a surjective mapping because every member of this codomain has been mapped. This one is not. Then we can as well have something like this: A, B, C, D, and then we have 1, 2, 3 on this side, and then we have something like this. This is also a surjective mapping because in surjective or onto mapping, what we look out for is that this codomain, every member of it, like every member of this set on the codomain side, has an element that it has been mapped to on the domain side. That is just what we look out for. We look out for this one. Everyone is mapped out. Okay. Then we also have constant mapping. For constant mapping, that is another type of mapping. But these two, injective and surjective mapping, they are the two major types of mapping. And then, do you see that this example is injective or one-to-one and also onto mapping? This is what we now call bijective, right? If it's bijective mapping, it's a one-to-one mapping and it's also an onto mapping. So we call it bijective. It's both injective and surjective. This is only injective, it is not surjective. This is only onto, that is surjective, but it is not injective. Why? Because these two are mapped into one. Like they don't have, every one of them don't have a unique element here that they are mapped to. So we also have constant mapping. So this type is just all about having just one element, having one element in the codomain. Let's say 2, for example, and then every element, I'm just using ABCD always, every element is mapped to that singular member of the codomain set. So range is just has one element. The codomain just has one element in constant mapping. They are all mapped to just one value. Then we also have identity mapping. Identity mapping, here we have that the codomain is also equal to the domain, or the domain is equal to the codomain, whichever way. So if we have ABC, this is also ABC. Like the same set, they are all mapped to each other. So that is when we have identity mapping. So these are the 4 types of mapping: injective, surjective, constant, identity. Or we can as well include bijective mapping, because that one is a mapping that is both injective and surjective. Now let's do some examples before we go. Which of these mappings are injective, one-to-one, surjective, onto, or bijective? So from our definition, every element here is mapped to a unique element here. So this is one-to-one, right? Everyone to its own special element here. Okay. And for subjectivity, every member of the codomain has been mapped, right? So this is a subjective mapping, right? Or onto mapping. And because it is both injective and surjective, therefore this is also bijective mapping. Let's look at the second mapping. For this, we can see that every element here is mapped to a unique, like none of them is repeated, none of them are mapped to a single thing. So this is one-to-one, injective mapping. But for surjective, we can see that this member of the set has not been mapped to anything. So this is not an onto mapping, and therefore it is not bijective. Then we look at this. These two have been mapped to one, so it is not onto it's not injective or one-to-one mapping, because not every member of the domain has its own special unique element here which it is mapped to. So this is not one-to-one. But every element in the codomain has been mapped, right? So this is an onto mapping, but it is not, of course, bijective. Okay, so we look at the D part of the question. We can see, so we can see that these two have been mapped to one element of the codomain set. So this is not a one-to-one. And as well, we can see that this has not been mapped. These two elements here have not been mapped. So this is not an onto mapping. It is not surjective. It's not bijective. It is none of the above. Then we look at this. We can see, yes, every member has been mapped to a unique member of this set. Therefore, this is one-to-one. And every member of the codomain was mapped out, right? So this is an onto mapping. And therefore, since it is one-to-one and onto, it is also bijective. Okay. Identify the type of mapping from the pairs below. So we can't really see the type of mapping, just like it's difficult to see. All we have to do is we are going to draw arrow diagram for each one of them. So for the first part, we have the first member of these pairs are in the domain, and the second member are in the codomain. Now for the second pair, B should be here, and then 5 should be here. B is mapped to 5. For the third pair, we have D mapped to 7, and then we have C mapped to 6. So we can see that this is a one-to-one because every one of them is mapped to a unique, right? To a unique element in the codomain. And as well, every member of this codomain set has been mapped already, right? So this is also an onto mapping, and therefore it is a bijective mapping. Now for the second part, we have A, which is mapped to 2. We have B, which is mapped to 2, right? We have C, which is mapped to 1. We have D, which is mapped to 0. Okay, so we can see this is not a one-to-one because everything here is not mapped to uniquely. These two are mapped to 1, right? To one element here. Okay, and then every member of this codomain set has been mapped already. So this is an onto mapping. It is not bijective.